Good day everyone, for today's video is all about the Midterm PIT and Robotics 1 or EMT 313, which is the web but custom running code. On the other hand, we will make a simple robot with C++ programming or other programming. But on this PIT, I will be using the C++ programming. But to proceed to the further discussion on this PIT, let me first introduce myself. Hi everyone, my name is Abigail Ballar from Robotics 1 EMT. And now let's proceed to the video. So now let's start. So let's go to Wizard, new project directory, next, and we're gonna change this to our name. And go to next, and add rectangle arena next, and finish. We're gonna wait first. After this, we're gonna go to rectangle arena and we're gonna change the floor size to 2. Next, Y is to 2 also. And after that, the wall height will become 0.05 since it is 0.01. So, after the rectangle arena, we can now proceed to our robot. So we're gonna click this rectangle arena, just go to add new. We're gonna wait for a minute, for a second. So after that, we're gonna see the add a node. So we're gonna go and click the base nodes and click the robot. After that, we're going to add. After this, since we have a robot already, we're gonna go and proceed to our body of the robot. So the first thing that we should do is we're going to children, just add new, and go to base node, still the same. We have add the node and go to base nodes and find the shape. Add. And now the shape, we're going to rename this as body. After we rename, we're gonna proceed to body shape. We're going to appearance, go to base nodes, and the same earlier. So we are now choosing the simple appearance. So we have here the PBR appearance, add. And we have here base color, so we're gonna change the color since I have a desired color. So the red one will be 0.50 5882. And next is our green is 0.74902. And our blue one is 0.3725 and 49. So this is our color for our body, and we'll proceed to metal nest and we'll change this to 0. So after we are done to appearance, we're now proceed to geometry. Null. So just the same, we're going to add new and go to box since we're going to do a 4-wheel robot. So we're going to change the box. So we're going to change this as X is still the same, and our Y is 0.05. So we're going to click first the shape and we're gonna move upward so that we can see it. So now we're going to we are done to our body, but after the geometry box, we are going to click the bounding object, just go to add new and click the use, and we can see this body shape and add. After that, we are going to click the physics and just go to base nodes and add physics. After this, since we are done to our body of the robot, we are now going to save it first, so we will not regret it. And since we are done to our body, we are now proceed to our wheel. So we'll just click the body shape and just click add new. Go to base node and add the or find the hinge joint and add. So in hinge joint, we are going to click first the joint parameters, add new, go to base nodes and select hinge joint parameters, and go to device. We're going to click add new and go to base node and select the rotational motor, add. So go to rotational motor and we are going to rename this as wheel 1. After that, we are going to proceed to our endpoint null. So the same, we're gonna add new and go to base nodes and find the solid and add. After this endpoint solid, we're gonna click this, and now we're going to click the children and go to base nodes and click the shape for our wheel. This shape, we're going to rename this as wheel. After that, we are going to click the appearance inside the wheel shape. In this appearance on our wheel, it has a different appearance, so we're going to find a nice appearance. So we have here the corrugated metal. We're gonna add this, and we will not be changing the color. So now we're going to geometry null, just add new, and we are gonna find the cylinder for our wheel and add. As you can see, we have here the wheel. So we are going to change the height to 0.02 and 0.04. So after that, we are going to proceed to our bounding object on a wheel. So we are going to add new base nodes, go to use and select wheel. Physics, go to add new, select physics, add. After that, we are gonna change this physics to physics WH. We're gonna rename this. So after that, we are now going to our translation. So our X will be 0.06 and our Z is 0.06 and our rotation is our Y is became 0, our Z is became 1, and our angle is 0.57. So now after this, we're now going to save our first motor, first wheel, I mean. So but there's one thing that we forget, the anchor, the same with the sizes of our translation, so 0.06. So after that, you're now going to save it again. We can also just copy this for our second wheel and just paste it. So we are now having our second wheel. So we are going to rename this device as wheel number 2, go to device, go to rotational motor, and name to wheel number 2. After that, we are now going to our endpoint solid. We are going to change the translation to negative, the x-axis. We're going to turn this to negative. And next is our joint parameters. The anchor first is our x-axis. We're going to negative, since this is the same with our translation. So now we are done for our second wheel, so we're gonna save it. Next is we're gonna copy this and we're going to paste it again. So now we are going to proceed to our anchor first. We're gonna turn our x to positive and our z to negative. And we're going to device, rotational motor, and rename this to 3. And after that, we are now going to go to endpoint and change the translation. X will be positive and z will be negative. After that, we're going to save it, and now we're gonna copy this and paste it. Now, same process, we're going to change the x to negative, the anchor, and now the wheel, we're gonna rename this to 4. After that, we are going to change the translation on endpoint solid for our fourth wheel and save it again. So next on this is the sensor of this robot. So now we're gonna click the hinge joint and just add base nodes and find the distance sensor. Add. So after this, we're gonna rename first the distance sensor to TS left. So now let's proceed to our distance sensor, or the appearance of our distance sensor, or the shape of our distance sensor. We're gonna go to children, just click add new, just click children and add new. So you're going to find shape for our sensor, and we're going to rename the shape as sensor. After that, we're gonna go to appearance on our sensor and go to base node, and we're gonna choose the appearance or PBR appearance, the same as our body. So after the appearance of our sensor, we're gonna proceed now to base color, and we're gonna change the color for our sensor to red, and go to metalness, change it to 0, and now we are done to appearance. We're now proceed to geometry. So now in our geometry, we're gonna select the cylinder for our, or we're gonna change it, reset first, and we're gonna choose box only. So now we are done to our box or size. So now we're going to change the size of our sensor. So the same sizes of this geometry box. So we cannot see it because nasa may ano pa siya, center. So now we are now going to proceed to our bounding object on our sensor, and add new, goes to base nodes, use, and select sensor, add, and now go to physics, add, and just click the physics and add. So we are now done for our physics, and we are now going to proceed to our sensor translation. So the translation of our sensor is our x is 0.1, no, 0.02. Wait lang, I have a copy here. So 0.02 our x, and our z here is 0.01, so 0.1. So are now going to, after the translation, we're going to rotation. So we're only change the angle, point, I joke, 1.27. So we are done now on our first sensor, which is the left. So we're going to save it, and after this we're going to copy and paste for our next sensor, which is the right one. So we're gonna rename this to right, and we are going to change our translation to negative so that it will move and go to, I think, rotation, and negative 5.7 or 5.9. So we are done to our distance sensor. Both of our distance sensor. Wait. So now we are going to check it all so that we will not gonna see anything here. So now we are now going to proceed to our controller, our program. So first, since we don't have a array for our distance sensor, we're gonna go and check to view and go to optional rendering so that we can see our distance sensor rays. So we are now having our distance sensor rays. So we're going to save it again. Okay, we're gonna cancel it first. We're gonna reset so that we can save it. We're gonna go again, but this time we have already a distance sensors. So next, so this is our distance sensors. So now we're going to proceed to our C++ program. So now we're going to proceed to our C++ program. So first we're going again to wizard. So the next to new project, we're now going to our robot controller. So just the same with new project earlier. So next, we're going to choose C++ program. Next, so webhooks. Next, and we're going to change this as Ballar controller. So next, and finish. So we are having this one, which is our controller, and next is we're going to find here the controller void, and we're going to select and this Ballar controller that we make. So after that, this is we are going to paste our program that we make. So we're going to delete this first and paste. So we're going to change our double left speed and right speed to 7, and this will become 7 also. So we're going to save our program. So after we save it, we are going to clean this, our console, and we're gonna wait to finish the clean. Now we have here the clean finish. We are now going to proceed this one, build. We're gonna wait for a minute or seconds. So we are done. So we have here the compilation successful. So we are going to X this one. So since it was finished already and we X the compilation successful, now we are going to run our robot or deer. Just click this, run the simulation. And now and this is my custom robot with C++ programming. Thank you everybody and have a good day.